Today we're talking about something really strange, like really strange. One of those experiments that makes you question how reality even works. You've probably heard of the double slit experiment before, but today there's a twist. AI got involved. So let's start simple. Imagine we fire a single photon at a wall with two tiny slits. Now here's the weird part. If nobody is watching, like no measurement at all, that photon somehow behaves like a wave, and it goes through both slits at the same time. Yeah, both. And on the screen behind, you don't get two lines. You get this interference pattern, like ripples overlapping. But the moment you try to check which slit it went through, everything changes. Now it acts like a particle. It picks one slit. And the pattern disappears. And no matter how many times we repeat this, it always behaves the same way. But here's something interesting. We've been doing this experiment for years, and somehow we never thought, hey, what if we let AI analyze all this data? Well, now someone finally did. And what came out of it is honestly pretty interesting. Before we jump in, quick favor. If you're into this kind of content, just hit the like button, subscribe, you know the deal. It really helps the channel. Alright, so what did we actually know until now? We always said the photon creates that wave pattern because it goes through both slits. But if you think about it, we never actually see that part. We only see the result on the screen. The middle part, the moment it passes the slits, that's basically hidden from us. And that leads to some pretty big questions. Does the photon split into two? Or is it doing something even weirder, like jumping between slits? Honestly, we don't really know. Because the second we try to observe it, the whole thing changes. So the idea was, what if we let AI look at everything we can measure, and try to figure out what's happening in between? That's exactly what researchers did. They collected tons of data from these experiments. Not just the final patterns, but also what the photon looks like before it reaches the slits. What happens after? And the final result on the screen. So basically, the beginning and the end. But not the middle. Then they trained an AI model on all of this. They showed it thousands of examples like, here's how it starts, and here's how it ends. And they asked, what could be happening in between these two? Think of it like this. You see an arrow leaving a bow. Then you see it stuck in a target. But you don't see the flight. Now imagine showing that to an AI, again and again, thousands of times. Eventually, it starts to figure out all the possible paths that arrow could have taken. That's basically what's happening here. Except, this isn't normal physics. This is quantum stuff. Now quick side question, because people always ask this. What if AI itself runs the experiment? Like, imagine robots doing everything. They measure, they record data, but they never show us the results. Does the system still behave like a wave? Short answer, no. It doesn't matter if there's a human watching or not. What matters is the measurement itself. The moment the system is measured, the interference pattern is gone. Now here's where things get interesting. Up until now, we had two main ideas. Either the photon somehow splits into two, or it does something like teleporting. But the AI came up with a different picture. According to the model, the photon doesn't split. But it's also not just a single point. Instead, it kind of spreads out. Like a structure that stretches through space. As it gets closer to the slits, it expands and sort of covers both at the same time. The researchers gave a pretty cool example for this. Think of a soft piece of dough. You push it through something with two holes. The dough stretches into both holes, but it's still one piece. That's kind of what the AI is suggesting. So what happens when we measure it? Well, imagine blocking one of those holes. The moment part of the dough interacts with something, it kind of snaps back, like elastic, and you're left with a single outcome. A single particle. Now, does this change quantum physics? Not really. This isn't some revolutionary new theory. It's more like a new way of thinking about what's happening. A different perspective. Interestingly, the AI also tried to explain why this happens. It suggested that interaction with the detector causes this snapback effect. But from what we know, that explanation might not be correct. So yeah, the idea is interesting, but we're not fully there yet. So what's the takeaway? Using AI to analyze scientific data, that's actually a really smart move. And we're probably going to see more of this. More insights, more patterns, maybe even surprises. But is AI going to suddenly rewrite physics? Probably not. At least, not anytime soon. There's also something else to think about. If AI starts doing more of this work, what happens to researchers? Especially students? If fewer people are involved in the process, does that slow down progress in the long run? That's a bigger question. Anyway, if you enjoy content like this, weird physics, AI, all that good stuff, make sure you subscribe, like the video, and I'll see you in the next one.